All right, this video is going to go over 15.1 A and B, which is log and exponential converting between the two and evaluating them. So let's go ahead and get started. Basically, you need to realize that these are inverses of each other. Like when you see exponential form and logarithmic form, these are inverses of each other. So you can convert between the two of them. The way I do it is the Snail method. So first of all, realize what form you're in. We're in log form. Realize what form you're going to. Well, we have to be going to exponential form and kind of know what that's going to look like. So here's the Snail method. Ready? You circle the first number, you swing around, and you finish at the 256. So the way this works is we're going to exponential form. It's going to look like this. The first number, this first 4, goes first. The next thing along this line is the next 4 here. That's your exponent. And then it finishes at equals 256. And that's all you have to do. So like this one would be 2 to the 5 equals 32. Now I will say, when you do this, you need to realize that the log needs to be on the left side in order for this to work. So like this one would be 5 to the 1 equals 5. And this one, 9 to the 5 equals 59,049. All right, this one, 56 to the 0 equals 1. And this one, 2 to the negative 10 equals 1 over 1024. So nothing to it. Now, when you're in exponential form, like these below it, you're going to log form when you snail it. So the first thing you should do is write the word log. All right, that follows the same pattern. So your first number was a 9. That's going to be the base. The next thing along this line is the 81. That's the of section of this log. And it finishes at equals 2, just like that. So like this one would be, write the word log. Your first number is 8. That's your base. Of 512. You can put it in parentheses if you want. It doesn't really matter when it's just one number. And then it finishes at equals 3. So this one would be log base 2 of 512 equals 9. And so you do that for all of these. I'll just do it real quick. Log base 5 of 625 equals 4. Log base 4 of 1 over 64 equals negative 3. Log base 8 of 1/8 equals negative 1. This one, stick to the plan. Log base 6 of 6 equals 1. Log base 17 of 1 equals 0. All right, now evaluating is a little bit different, but it's not that bad. All right, so whenever I evaluate, I put an imaginary equals x, just like this, okay? And then I snail this. So I'm taking it to exponential form. So it's like 2 to the x equals 8. Now, a lot of them, you can just use common sense. Some of them, you'll have to solve it like an exponential and actually take it to like 2 cubed, and then you'll be like, oh, okay, x equals 3. It's however you need to solve it once you get to that point. What you need to realize is, though, you made up this x. It does not exist. So when you write your answer, you don't write x equals 3. No, there's no x there. You made that up. It's just 3. So like in an equation, if you had this piece here, you could just replace this whole thing with 3. That's what I'm trying to tell you. But you don't write x equals 3. You just write 3. So like this next one, imaginary equals x. So when you snail it, it's like 2 to the x equals 2, aka 2 to the 1. So this one's just 1. This one, 8 to the 3 equals x. This one was a little different because it actually does have an x. So this one's just 8 cubed equals x, which I think is 512. Okay. This next one doesn't have anything, so I imagine an equals x and I snail it. Now this one you would probably need to break it down. It's like 3 to the x equals 1 over 27. Change that to be 1 over 3 cubed, and then change that to be -3 there. So this one's just -3. That's an exponential solving problem. Okay, same thing with this one. Snail it. So you're like, okay, well, 2 to the x equals 1/8. Break down 8, it's 2 cubed, and then bring it up to the top. You'll get 2 to the -3. So this one's just -3. This one, 5 to the x equals 625. So that's 5 to the power of 4. So this one's just 4. Okay, this one, 3 to the 4th equals x. Well, that's 81. This one, 2 to the 5th equals x. That's 32. So that's how I evaluate these things. All right, let's look at some more. Okay, this is a very popular problem, this one right here, because what's going to happen is you're going to snail it and put your imaginary equals x. So it's like 3 to the what power gives you 1. The only number that could go here to make this work would have to be a 0, because anything to the power of 0 is 1. So this one is just 0. That's a very, very, very common problem. So like this one, 9 to the 0 equals x. 9 to the 0 is 1. This one, 5 cubed equals x. Well, that's 125. 11 to the power of something equals 121. Well, that's 2. It's 11 squared. 8 to the power of something equals 8 to the power of 1. Well, then it's just 1. 2 to the power of something equals 1/4. Well, this right here is 2 to the -2. So it would just be -2. 3 to the 5th equals x. That's 243. 9 cubed equals x. I think that's 729. Okay, this one, they're saying there's this bacteria that divides every hour, and they give this equation after t hours is given. So how many hours? So we're looking for t. We don't know this. And they say, will there be 32 bacteria? So it's like this, the 32 plugs in for the n. So when you snail this, it's like 2 to the t equals 32. Well, 32 is 2 to the 5th. So my answer would be 5 hours. Okay, now one thing you need to know is you're going to see log without a base. When that happens, by default, it's a 10. So all of these have base 10. All right, and so when you do these, it's going to be like 10 to the what power equals 0.1. Well, 0.1 is 1 over 10, 1/10. And then you should be able to realize, well, that's 10 to the -1. So this one would just be -1. Okay, then when you get the big numbers like this, so that was a decimal. When you get the big numbers like this next one, you'll go 10 to the power of something equals 100,000. To figure this out, you just count the zeros. There's 5 zeros there. So this is 10 to the 5th. So this one must just be 5. So like this one, 10 to the what power makes 10,000? Well, that's 4 zeros. So that's 10 to the 4. So this one's just 4. The next one would just be 10 to the what power makes 1,000. Well, that's 10 cubed, so this one's just 3. And then this one, 10 to the what power makes 0.01. Well, that's 1 over 100, aka 1 over 10 squared, aka 10 to the negative 2. So that's how I would have done that one. Now, you're going to get some weird ones like this, and I don't think I'm going to do this page. I think I've basically covered what I need to cover so far, so we'll just finish up these 6 and then call it. But you are going to get some special cases like this where it's not always super nice and easy to understand. So let me walk you through these. You're still going to imagine it equals to x, and you're still going to snail it. So it's like 27 to the what power gives you 3. All right, well, this is an exponential problem that you have to go solve. And so the way you're going to do it is you're going to want to get the same base here. So I need this 27 to be in terms of 3. So 27 is 3 cubed. Let me do it in a different color. 27 is 3 cubed, but I still have that to the power of x there, right? So it's really like this. Well, this turns into 3 to the 3x. It's power to power, just multiply them. Equals 3 to the 1. Now you can just set these exponents equal to each other, this part right here. So you can just go like, okay, well, 3x equals 1 and divide by 3. X is a third. But again, you made up the x equals. So you would just replace it with 1/3, not x equals 1/3. So like this one, 16 to the what power makes 8. Well, you can't take it to base 8. That wouldn't work. You have to take this one to base 2. So this is like 2 to the power of 4. And then this is 2 cubed. And so you get, okay, well, 4x equals 3. Divide by 4. You get 3/4 for this one. This is the key, though, being able to do this right here. That's very, very important, getting the same base. All right, log 8 of negative 64. Now, this is a huge red flag, this right here. You're basically saying 8 to the what power could make negative 64. Well, if you think about it, no matter what number you plugged in, if it was -1, it'd be 1 over 8. If it was 0, it would be 1. If it was 2, it'd be positive 64. You're never going to get a negative number out of this. There's no exponent you can put there that'll spit out a negative number. It doesn't work like that. So you should always be on the lookout for log of a negative number. If you see log of a negative number, it's an instant no solution, or you could say it does not exist. Maybe like a D and E does not exist. That's an immediate, it does not exist. That's not possible. So like even like this one right here, 41, you're basically saying 5 to the what power gives you 0. Well, the lowest it could possibly go would be like 5 to the 0, which is 1. Because even if it was like 5 to the 1/2, it'd be the square root of 5, which is like 2-ish or something. Or if it was like 5 to the -2, it's still a positive number, 1 over 25. You're never going to get lower than 1. So if you see log of a negative or log of 0, it's an instant no solution, or D and E. So if it's a 0 or a negative number, no solution. You cannot do that. All right, let's finish up these last two. This one basically 81 to what power gives you 9 to the 1. You got to take this to be, you could do it in 3s, but I wouldn't. I would just do it in terms of 9s. I'd be like, okay, well, this is 9 squared. Now it's just 2x equals 1. Divide by 2. It's a half. But I don't write the x equals. Remember, I just write a half. Okay, and then this last one. 16 to what power makes 64? Well, you can't do this in terms of 16s. It won't work. You could, no, we're going to do it in terms of everything to the power of 2, or base of 2s. So like This is 2 to the 4, 16 is. And then 64, if you break down 64, it's 2 to the 6, like this. So you just go, okay, well, 4x equals 6, divide by 4. You always reduce, and you'll get 3 halves. So that's a 2. All right, so that is how I do logs. They are very important. They're not so bad as long as you know the Snail method, and you're always on the lookout for log of negative or log of 0. Those are instant no solutions, and they're trying to trick you. And then, like, if you get the weird ones, just get your base the same on the exponential part. This is really important to be able to do. Otherwise, it's not very difficult. Hope this video helped.